Okay, this lesson will be on graphing linear inequalities. Okay, so it's a lot of the graphing line stuff that we've been doing, except we're going to graph an inequality. I want to talk about a couple things first. All right, basically, the only difference that separates this from graphing is you're going to have maybe a possibility of the change in the type of line, and you're going to have some shading. So here's some basic notes. All right, and when we look at this, we're looking at in conjunction to the y. Okay. If I've got y is greater than or equal to, okay, that is going to be a shade above, okay? And as we get to the examples, this will make sense, so you can keep accessing it. It means shade above the line, okay? If you have y is less than or equal to, you're going to shade below the line, okay? So that is important. Y is greater than, shade above. That's the same thing as if it's like this. Okay? If you notice, it's like the mouth of the inequality is eating the y. Okay? Eating the y, shade above. Same thing here. If you have this action, this is also a shade below. It's not eating the y. Okay? That's one thing. Okay? The next thing that you're going to need to know is that if it's one of these, you're going to have a dashed line when you graph it. If it's one like this, you're going to have a solid line when you graph it. That is important, okay? All right, I'm going to get to one that's just x equals in a little bit. We're going to stick with this y concept, okay? All right, so let's go through an example. Let's say I have y, okay, is less than or equal to negative 5x plus 3x plus 5. Okay, so what I'm going to do is I'm going to graph the line like I normally would, okay? All right, so I'm going to start at the 5, so 1, 2, 3, 4, and 5, okay? All right, then my slope tells me from this point go down 1, 2, 3 to the right 1, okay? Now, since my inequality has this line underneath it, I can go ahead and make a solid line, okay? All right, now, I got to figure out, well, what kind of shading is this going to be? Well, since it's not eating the y, this means it's going to be below, okay? Now, if you ever get confused of above and below, all right, just draw this arrow like that. That's always up, okay? All right, that's the up side. That's the above side, okay? Below would be over here, okay? This is the below side, all right? And that's all you have to do, all right? Let me do another one, okay? Let's say I have y is greater than 1 half x minus 4, okay? So here, I'm going to start down 4, 1, 2, 3, and 4. Put a point. Then I'm going to go up 1 to the right 2. Now, since I don't have a line underneath this, I'm going to have a dashed line that you can make this way, okay? Y is greater than, okay, so that's eating the x, so that's going to be the above side, okay, which is going to be this side. That's going to be above the line, so I just shade it like that, okay? That's another example, okay? Let me give you another type that you can see. You might sometimes get something like this. F of x is greater than or equal to, let's say, negative 3/4 x, okay, minus 1, okay? Now, f of x is just a fancy symbol for y, so don't get confused with that. So what I'm going to do is I'm going to start at negative 1, and since it's negative slope, I'm going 1, 2, 3, always to the right 4. Okay? Now, what kind of line is it? Because I got that underneath it. I know it's going to be a solid line. Okay? It's eating the y, so it's going to be on the above side, which will be this side. Okay? All right? Another type of example you could get would be y is, let's say, less than 6. Okay? Now, this is one of the special ones. 1, 2, 3, 4, 5, and 6. Okay? It is a Hoy problem, so I'm going to have a dashed line going that way, all right? Since it's not eating the y, it's going to be the downside, which is going to be down here. I can just go ahead and shade all that, okay? All right. Now, the tricky part sometimes comes into what happens when it's one of these. Let's say it's x is greater than or equal to -2. Okay? Now, we know from graphing that -2, that's a Vux problem. So it's going to be a vertical line. Now, all right, here's the deal. You don't see an above or below here because it is an x. You have a left and right, okay? So if it eats the x, okay, that's greater than. Okay? Greater than is on this side. Okay? Greater than is on this side. Let me do another one. Let's say I had x is less than 5. Okay? 1, 2, 3, 4, and 5. Okay? A dot. A vertical line. Now, since it's less than, I'm going to be all the way over here. Okay? So if you can graph those lines, all right, you can graph the equations. Okay? Or you can graph the inequalities. All right? Now, I want to switch gears for a second and go to the other type of graphing, which is graphing ones like this. Okay? Now, here's the deal. What I'm going to do is I'm going to solve them the same way I've done before. I'm going to put my little inequalities here, okay? X is greater than, less than 8. I'm going to divide by 2. X is less than 4. I'm going to take 4y, divide by 4. Y is less than 2. When I go to graph that, x4, 1, 2, 3, 4. y2. Now, same thing, my inequality is this, so I'm going to have a dashed line. Now, here's the key thing to know. When you have these, all I care about is what's happening with the y. So in this case, it says y is less than, so that means down. So I'm going to graph on the down side of this. Okay? Let me do another example. All right? Let's say I have 3x plus 4y is greater than or equal to 12. Okay? So what I would do is 3x is greater than or equal to 12. That's going to be 4. I'm going to divide by 4 on that one. That's going to give me 3. So when I graph this, okay, and what I'm going to do, it's going to be a solid line, okay, and then I'm looking at this. What's going on here? At y is greater than, so that's going to be the above side. Okay? All right. Now, there is one thing you have to watch out for when you do these. If I have something like this, 5x minus 2y is less than 20. Okay? I got 5x is less than 20. I got negative 2y is less than 20. I divide by 5 here. That's going to be x is less than 4. I divide by negative 2 here. Now this is important. Only for the y does this matter. If I divide by a negative, I've got to turn that inequality around. Only for the y, not for the x. Okay? Okay, so this is what I got here. Alright? So if I were to graph this, 1, 2, 3, and 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Down here. Okay? Now, what I'm going to have is I'm going to have a dashed line. Okay? Now, I only care about the y here. What's the y doing? It is going up. So I'm shading on the above side. I do not look at the x to determine the shading. Okay? Let me do another one. Okay? Just so you catch the idea. If I have this for some reason, okay, I have negative 6x less than or equal to 24. Divide by negative 6. If you want to flip that inequality around, that is fine. Okay, this one I would divide by 3. Now, all I care about is that one. That this flipped around does not change my shading. Okay, so when I graph that, I am 8 up. 1, 2, 3, 4, 5, 6, 7, 8. I am negative 4 to the left. I am a solid line. Okay? And all I care about is this, y greater than. So that's going to be shaded that direction. Okay? And that's how you do that, that inequality there. All right? And let me talk about what the shading means. Okay? Let me talk about what the shading means. Okay? The shading basically means that if you have, and let's go ahead and just keep practicing, because practice is good. Okay? If I had something like that, I'd start down 7, then up 1, 2, 3, 4, 5 over 1. Dash line. Okay? Since it's y greater, I'm shading above. Now, what that means for me, pretty simply, is this. If I were to pick any point, let's say a point right there. Let's say that point's 1, 0, which I believe that's gonna work for us. Okay? If I put 1 in for x and 0 in for y, okay? 1 in for x, 0 in for y. If I calculated that, would be negative 2. So this says 0 is greater than negative 2. Yep, that is a true statement. Okay? So when you're shading, that's what that means. Okay? So graphing inequalities is no different than graphing lines. If you can graph the lines, you can graph the inequalities.